Welcome to Maths for All. I'm Aisling Flynn. This is complex numbers 1.5, equations with no real roots. So solving equations without real roots. So normally when you get a quadratic equation, so x squared plus something x plus a number equals 0, what it looks like on a graph, this is not to scale or this is not right, is a U-shaped graph, and it crosses the x-axis at 2 points. Okay, and these are what are known as your roots, and these ones are real roots because the function crosses the x-axis at 2 points. Okay, if instead you have a function, for example, the one we have here, z squared plus 5, okay, it does not cross the x-axis, okay? So what are its roots? Okay, so there are no real roots. So let's go through this example. Z squared plus 25 equals 0. In this case, we don't have to factorize in all the usual because we've no middle term. We'll take 25 from both sides. We've z squared equals minus 25. So usually the next step would be to get the square root of both sides. So that gives you z equals the square root of minus 25. But we have learned that a negative number does not have a real root. Okay, so in this case, we introduce I as the square root of minus 1, and we get z equals plus or minus 5i. So plus minus, it means that one of the roots is plus 5i and one of the roots is minus 5i. So as with all quadratic equations, we do get two roots. In this case, one is plus and one is minus. Okay. So let's solve this one. So this one is a trinomial, meaning it has 3 parts. Okay. You could try to factorize, all right, but you would not find factors that will work for these numbers. So instead, now we'll use the quadratic formula, okay, or as we call it, the minus b formula. It's in your formula books on the algebra pages. Okay, so in this case, right, well, substitution is done here, but you can see that a is 1 from above here, b is minus 8, which is here, and c is 25. All right, so you substitute in for the letters into the formula, and let's see what it looks like. So you get 8 plus or minus, so 64 minus 100. And what happens is you end up with a negative under the square root. Okay, so we have the square root of minus 36. So if you think back to the start of your, when you learned about imaginary numbers first, this is 36 by minus 1. Okay, now the square root of 36 is 6, and the square root of minus 1 is I. So that's what you get. But don't forget, it could be plus 6 to give you 36, or it could be minus 6 to give you 36. All right. The other thing that we can do here is, in this case, well, let's see. So we have 8 plus or minus 6i, and in this case, the 2 can divide into each term on the top separately. So 8 divided by 2 gives you 4, and 6 divided by 2 gives you 3. So the roots of this equation are 4 plus 3i and 4 minus 3i. Okay, so keep those in your head now for a moment while we go to the next slide. So here we're asked to solve this equation. Okay, so we're going to use our minus b formula. Why am I going straight to it? Because the question tells me to give your answer in the form of a plus bi. So as soon as you see complex numbers, you know you're wasting your time trying to find factors. Okay, make my list. A is 1, B is plus 6 and C is plus 10. Okay, let's fill it in. So we'll get x is equal to, or in this case we're doing z. Okay, so I should change that to z. That's my variable. Is equal to minus 6 plus or minus the square root of minus 6 to be squared minus 4 times 1 times 10. That's 4ac. And that is all to be divided by 2a, 2 times 1. Okay, now you can do this, well actually you can't do this on your calculator because it will return an error, because the calculator will not give you the square root of a negative. So we'll go through this bit by bit. Minus 6 plus or minus, now minus 6 squared is 36, and we've got minus 4 ones are 4, and 4 by 10 is 40. Okay, so we have 36 minus 40. Z equals minus 6 plus or minus 4 under the root. Okay, there's our negative as expected. Z equals minus 6 plus or minus, now what will we get for the square root of 4i? Well, the root of 4 is 2, and the negative means we'll have an I with it, okay, over 2. And in this case, yes, we can divide into 2 to each term. We get Z equals minus 3 plus or minus I. Okay, so in the previous examples, the roots of each equation were two complex conjugates. Okay, so we had something, I can't quite recall, it was 4 plus 3i and 4 minus 3i. The previous one there was minus 3 plus I and minus 3 minus I. And the very first one we had plus 5i and minus 5i. So they appear as conjugate, and they're conjugate roots. Okay, so, and this is the case for all of this type of equations. If the complex number z, a plus bi, is a root of the polynomial f of z, okay, we'll explain the big words in a minute, with real coefficients, then z bar a minus b I, which is the conjugate of z, is also a root. So what does that mean? It means if you have a polynomial, well, that just means a multi-part equation, like a quadratic equation, okay? If you have a complex number as one root, well, then its conjugate will be a root also, okay? And that's known as the conjugate root theorem. So, and when you substitute in for your z into the function or the equation, you'll get 0 equals 0, okay? And that proves it's a root, it makes the equation true, and the same goes for its conjugate. Okay, we'll do some examples. Okay, if z equals 3 plus I is a root of the equation, z squared minus 6z plus k equals 0, find the value of k and write down the other root in the form of a plus bi. So we have two tasks here. The first one is to find the value of k. Firstly, the information given says that z equals 3 plus I is a root. That means if we substitute for z, so we get the function of z, we should get answer 0, or we should be able to make 0 equals 0. Okay, so let's try that. So substituting for every place you had z in the equation, you put 3 plus I. Now multiplying that out, so I often write the two brackets beside each other so I don't miss the middle term. Okay, we get this next line. Okay, pause if you need to work it out for yourself. Straight away there as well, I'm going to circle I squared because we know that can be replaced by minus 1. Okay, when you tidy things up, you see that you end up with 0i, so they disappear altogether, and we're left with real numbers. So essentially we have 9 take away 19, so we get minus 10 plus k equals 0. Then add 10 to both sides, you get k equals plus 10. So that's the first task. Alright, so you're working on basically it's the factor theorem. If something is a root, it will make your function true. It will make 0 equals 0. Okay. Now the second task asks you to write down. Okay, so pay attention to the words. If it says write down, it means you have no workings to do, you have no calculations. The answer should come immediately and you just have to write it down. So think back to the previous slide. We said if we have a complex number as a root, then by the theorem, its complex conjugate is another root. So by the conjugate root theorem, the other root is 3 minus I, so or z bar. Now, next one, show that 2 plus 5i is a root of this equation and write down the other root. Okay, so what we're going to do here to show me, or sometimes they use the word verify, we're going to demonstrate it. We know that if this is a root, we should get 0 equals 0. Okay, we make the equation true. So we have 2 plus 5i to be squared minus 4 times 2 plus 5i plus 29 should be equal to 0 if this is a root. So again, write out your bracket by beside each other. Okay, we get 4 plus 10i plus 10i plus 25i squared. Now as soon as that pops up, highlighted, it's minus 1. Okay, and multiplying the minus 4, we get minus 8 minus 20i plus 29. Is it equal to 0? So this is what we're investigating. Okay, so let's tidy up a bit. Real numbers, we get 4. Now, I squared makes this minus 25. We have a minus 8. And we have a plus 29. Okay, with i's, we have 2 10s there, make plus 20i. And here we have a minus 20i. So plus 20i and minus 20i automatically gives 0. Let's look at the numbers. So positive, we have 33, and negative, we have minus 33. So there we get 0 equals 0. And you can say 2 plus 5i is a root. Okay, and here's our second task. Write down the other root. So it's automatic by the conjugate theorem. If 2 plus 5i is a root, then its conjugate, 2 minus 5i, is the other root. And that's that. Okay, now you do that. Check your understanding with the quiz and practice the written exercises of the same name.